Hello, it's me again. So, with regard to that homework problem I just sent you, this is the way This is the equation to calculate the equivalent rate over multiple periods. Okay, so this was equation 5.1. Okay, so basically, this is the way I got that 50 point, I think 6% over 7 years. Okay, so once I got that, then I was just able to basically pop that and get the present value. Right now, this example here, they're showing you the future value. All right, but we can do the same thing with the present value. Once we have the interest rate, we can do whatever we want. So here we are doing an annuity of a future value, and I don't know if they show the same thing with the present value. Let me look. Maybe there's an example here. Anyway, here's equation 5.2. These are important equations. And here's to convert an APR to an effective annual rate. But in that problem, they gave you an effective annual rate. Okay? And here they are. So, but what I'm looking for... Oh, so here we are. So here basically is a problem where we basically... And here we're calculating the present value. And again, this was like the $70,000 in our problem. So here was like, this was like the 70,000, and here's our number of periods was 6, right? 6 7-year periods, and here was the rate, but our rate was over 7 years, and then we calculated the present value. So this is like an annuity that paid out $4,000 a year, and this is the lump sum you'd receive. All right, I just wanted to show you this from your book, so I hope everyone's clear on this. And there's a nice video here. So let me see if I can play this video.
Converting the APR into a discount rate. Okay, you need a new phone system. You can either lease it for $4,000 a month or pay upfront $150,000 for the phone system. At the end of the lease, the phone system will be useless because it only lasts 4 years. To make this decision, what you need to do is compare the present value of paying $4,000 a month to an upfront payment of $150,000. Let's put the lease payments on a timeline. Okay, to determine the present value of these payments, we need to discount them, and for that, we need a rate. Now recall what an APR quote is. It is not the actual interest rate you earn, but simply a way of quoting interest rates. So if the interest rate, as it is in this problem, is quoted at 5% APR with semi-annual compounding, you are actually paying, in this case because it's the loan rate, half of 5% every 6 months. So you're actually paying 2.5% every 6 months. Now, if you're paying 2.5% every 6 months, how does that now convert into a monthly discount rate? Because as we can see from the timeline, the cash flows are monthly. To answer this question, consider two loans. One loan, you have to make semi-annual payments of 2.5%, and the other loan, you have to make monthly payments. What monthly rate would make you indifferent between these two loans? You are indifferent between paying 0.4124% per month and 2.5% every 6 months. Now that we have the discount rate, we just use the annuity formula to calculate the present value of the payments. The payments are worth about $174,000. So you're better off paying cash today than leasing